Back to another exciting day in mathematics. Whoop, whoop. Warm up 120 should come up on your screen. And once again, this is being recorded. And reminder, we still have a lot of people on campus that are dropping into the classroom, so make sure your mobile devices are put away. All right, so with that said, I'll give you guys some time for number 120, and then I'll send you the screen so you can send that in. And one thing that I don't understand at times is that I give you guys about 7 minutes, maybe 10 minutes, and then when I call the first person just for the mean, which is the first thing you should have, you don't know. What? How is that possible? Ah. All right, so far so good. Mu is 6.4, variance 12.8, standard deviation 3.6. So that brings us to 10 on the up end, 10.0. On the bottom end, we are at 2.8. That's our norm, from 2.8 to 10. We need a z-score for 5. Z-score for 5. Go Z, let's see, Z. Let's go with Cole. What'd you get for the Z-score for 5, Cole? Negative what? Negative 0.39. All right, so that is about negative 0.39 is about right here. And if you got something like that, all right, good. And the range, what's the range? Letter R for Mr. Q. Oh, that's 9. All right. However, now they want us to find the area to the right of Z, which means we need to first find the area to the left of Z, because that was a home play. Is that correct? All right, tell you here the decimal equivalent of that. Then we're going to pass this to Dieli and see what she got for that decimal before we go to the right side. Tell you here what you got for that decimal to the left of negative 0.39. All right, what is that decimal, Dieli? 0.3483. it is, okay, and if we move the decimal to the right, that is 34.83%, okay, but that's to the left. They're asking us to find the area to the right of that. Tell your neighbor what to do, and then we're going to pass this back over here on this side to, how about Austin S. All right, what do we do, Austin, to find that area to the right? Subtract it from 100%, and that gives us, let's see, 65.17. Is that correct? Let's go. All right, and that's the area under the curve. Send that in, please. Good review from last night's home play, yeah? All right. Copy the agenda, warm up 120, normal distribution, and home play is 5 problems only. 5 problems only. Thank you, Mr. Q. You're welcome. I got you. All right, here's the code to access the home plate tonight. 8HNZ4, write that down. 8, H, and Z4. 8, H, and Z4. All right? And last night's home play was these 10, so go to Canvas, turn that in. There's a new module titled Module 6, Normal Distribution, and also turn in your second home play. Tell your neighbor the second home play. What else were you supposed to do last night? Yeah, your signed screen, yes. Turn that in as well, so I'll give you guys some time. This is tonight's home plate, 5 problems only. Yeah, it's not that much. Can I show what? The code for home play? 8, H, and Z4. All right, and get a Cornell note ready. We're moving on. Let's go. All right, here we go. I can define and compute normal distribution. I can define and compute normal distribution. Tell your neighbor what normal distribution is. I hope you know, because if not, I'm going to send Aaron to slap people around. My goodness. Normal distribution, a.k.a. bell curve. All right, so yesterday we said we know what probability we've been working with. We know the variables we've been working with, but we said that we're going now from discrete to what? To continuous. That's where we're headed. From there, we talked about the 3 different bell curves, the normal or the symmetrical one that we said has mean, median, and mode at the center. That's why it's called what? The measures of what? Central tendency. Whereas skewed left has mean, median, and mode in order from left to right. Skewed right has mean, median, and mode from right to left in order as well. Not all of them bunched up. From there, I gave you guys some percentages. Let's see if you remember from on top of your head. I'm sending you that to your screen. Start typing in some percentages. See if you remember without looking at your notes. Five, 4, 3, 2, 1. Bam. There it is. Some of you pretty close, yes? Notice on mine I don't have the ones on the end. Tell your neighbor what those percentages are. This N and this N. What are those percentages? Let's see, looks like Max got this. What are those percentages, Max? .14% on each end. That is correct. Woo! Max in the house. All right, we got that. From there, we talked about the Z-score formula, which is automatic already. If I was to give you a pop party on it, you got this, yes? Then from there, we moved on to the Z-score chart. Does everybody have that in front of you? Yeah, show your neighbor what's the left side of mu and what is the right side of mu on that chart. All right, we got it, yes? All right, so with that said, y'all ready? Yesterday, we said we can find the area to the left of Z 2.06. We first sketch our bell curve, sketch the area, look at the chart, get the decimal, make that into a percentage, and that's what we got, yes? From there, we went to this one, and then from there between it, 2 Z-scores, and so on and so forth. Today, we're moving on to this one. Copy this one onto your notes, please, completely, so you can have at least one of them. Example Q reads, write the following as a probability and find the area to the left of Z 2.03. So, I'll give you guys some time to write that down, and I want you guys to do the second part. Find the area to the left of Z 2.03 as practice, just to make sure you got it. All right, I'll give you guys some time. Copy and go. All right, here it goes. Y'all ready? So, to recap what we did yesterday, here goes the process. Step 1, sketch your bell curve. Step 2, sketch your Z-score. This is 2 standard deviations and a little bit more, so 1, 2, and a little bit more. It's about right there. Okay. We've been practicing that on the warm-up, Mr. Q, all year. Thank you for giving us that practice. You're welcome. All right. However, they want us to find the area to the left, so we shade everything to the left of that Z. Now, this is going for those of you that were absent yesterday, and for those of you that didn't do your home play. What do we do from there? Oh, from there we get our chart, Mr. Q, and look for Z 2.03, and Z we find it's at the right of mu. Okay, at the right of mu. All right, so let me go to my chart. Mu is right here in the center. Mu is in the center. I'm going to the right. 2 point, where's 2 point? 2.0 is right here. And it was what? 2.3? 0.3. So then I go to 0.3, which is up here. Then I intersect both this one and that one, and we end up with this decimal, which is 0.9788. Is that correct? All right. So that means the decimal equivalent of that area is 0.9788, and if we make that into a percent, we move this twice, so that is 97.88%. And if you got that by yourself? All right. But today, we're adding one more component, which is this one. Write the following as a probability. How do we write this as a probability? Here it goes. The probability, and this is where we're headed, guys. I'm trying to put all the nuts and bolts together because we're about to get into the word problems where you have to do all of that from a word problem. So it might sound something like this. What would be the probability that Maximus would fall in that area to the left of Z? How do we write that in symbols? It would be like this. The probability of somebody falling within the area to the left of Z is less than or equal to 2.03. Let's see if you understand what it says here. Z is less than or equal to 2.03. Here's 2.03. What's less than that? Well, everything to the left. And does it include Z? Yes, because it's got an equal sign. So less than or equal to that. Copy that, please. So this is what we're adding today. This portion, writing it as a probability. Okay, bonus question. Ready? Come back, people. Everybody here? Bonus question. But what if I didn't want to write the probability of everything to the left? What if I want to write the probability of everything to the right? Tell your neighbor what to write. What would I write as the probability of everything to the right? As a probability, how would I write that? Tell your neighbor. All right, how would I write that? Let's go with Brandon Darty. P is what? Hands if you got that. P is greater than or equal to 2.03. Are all these values greater than Z? Yes, that is correct. All right, let me send you the screen. Send me your notes since you guys are taking copious notes. Appreciate it. Send that in. All right, that was example Q. Let's go to example super Q. Copy this one, example super Q. Write the following as a probability. Find the area between Z 1.35 and Z negative 1.25. So once again, I want you to do first the second part, and then we'll come back to write the probability. All right? Give you some time. Copy and go. Okay, so take the z-score of 135, and where do I place that? From the center I start. Right here. All right, hands if you got that so far. All right, that is the red one, and we need the area first to the left of that. All right, tell your neighbor the decimal equivalent of the red one from your chart. What is the decimal equivalent? And Austin's going to enlighten us. What is the decimal equivalent of z-score 1.35? All right. All right, Austin. T, what'd you get? Point what? 115, which turns into 91.15%. Hands if you got that. All right, not bad. Next, in green, I'm going to send the second one. Help me with that one. Pass one, Austin. Brandon Doherty. Where do I go from you? Where do I go from you? To the left. Tell me where to stop. Right here? Okay, let me start again. All right, so here's our Z approximately. That's that one, and you found the decimal equivalent for the area to the left of that, and that was what? Point what? Which turns into 10.56%. However, they want the area between, so we need this area. So tell your neighbor what to do with that in order to find that area, please. Then we'll have Austin enlighten us. How do we find that area? All right, Austin S., how do we find that area? Subtract the two percentages. That is correct. And that gives us 91.15 minus 10.56. Calculators calculate. Mario, what'd you get? 80.59%. And that is the area between both Z's. And that was last night's home plate. Cake, yeah? We got it, right? However, we need to find a probability just for this section. So here, let me show you how to write that. Look up, please. So the section is from here to here. Is that correct? So this is how you write it. What is the z-score here on the far left? The z-score is negative 1.25. What is the z-score to the far right? Z-score to the far right is 1.35. And for those of you that were with me in Algebra 2, this is going to look familiar when we write the z in between, less than or equal to, less than or equal to. This is a compound inequality. That look familiar? Yes? All right, send me your notes, please. And that's how you write the probability between two z-scores. All right, go to another one. Example negative Q. See if you can do that one completely by yourself. Write the following as a probability. Find the area to the right of Z negative 3.17. I'll give you a head start. Copy and here we go. Walk us through this. Who haven't we called on in a while? How about Logan? What do I do first? On the chart, so starting from you, where do I go? To the left, tell me where to stop. About right here. All right, hands have you got up to right there so far? But now we need to find the area to the left. You're like, Mr. Q, but it says to the right. I understand, but we first need to find the area to the left. So what is the decimal equivalent of this area to the left? Pass it to Sam. All right, Sam, what'd you get? 0.0008. If we move the decimal twice, that becomes 0.08%. Hands, have you got that? That's all good and dandy. However, they're asking us for the area to the right. Tell your neighbor what to do to find the area to the right, and then Sam's going to pass someone. What do we do to find the area to the right of that Z? All right, Sam, pass someone. Who? Logan? Subtract that from 100%. That is correct. So the area to the right should be 99.92%. Hands, have you got that by yourself? Very good. That is correct. And once again, that was last night's home play. However, are we done? No, Mr. Q, we need to write the probability. Okay. How do you write the probability? Well, probability of Z and negative 3.17. Tell your neighbor what to write there. What do I write there for the area to the right? What do I write there, Amelia? Z is what? Less than. Z is everything to the left. Greater than or equal to is everything to the right. Hands, have you got that? All right, from 1 to 5, I'll come to you with this. Yeah, we got it. 4 5s, 4 5s, and a 3.5. All right, send me your notes, please. Hold on, let me send you the screen. There it is. All right, so with last night's home plate practice and today's practice, which is the same thing, all we're adding is the probability, writing it out, I think we're ready to crank it up a bit, right? Y'all ready? Yes? Everybody go like this? Bear with me. All right, here it goes. Y'all ready? Bam. Example super duper Q. Copy that one, please. Oh, yes. It says, write the following as a probability. Find the value of Z. Let's go now. Oh, yeah, we got this. They give us a bell curve, and they give us an area under the curve, which is 8.23%. Copy that, and then I'll send you that to your screen. I'll give you some time so you can sketch it nice and neat. Not like some of you that are writing with your feet. My goodness. All right. So everybody copy that already. So here we go. Let's do this one together. All ready? Mal, you ready? Okay, here it goes. In order to write our probability, we need a z-score. Is that correct? Do we have a z-score? No. But this one has pretty much the ending of what we were doing on the other columns. Is that correct? So if we think about it in reverse engineering, If this is the last step, tell your neighbor what was this before it became that. Talk to your neighbor. What was that before it became that? Ooh. David, what was that? He said a decimal before it was a percent. Okay. So what was that decimal? Aaron. What? Okay, guys, how many times do we move the decimal to make it a percent to the right? 2. So if we go backwards, we move it how many times? Yes, 0.0823. That's our decimal. Okay. Where did we get that decimal from? Mario? No. Where did we get that decimal from? The percentage. But if we're reversing engineering, where are we going to find this decimal exactly like that? In the z-score chart. So go to your z-score chart, look for it, and by the way, Maximus, here's M for Maximus. On what side are you going to look for on your chart? On the left, because this is on the left. So look for that decimal, please. All right, let me bring my chart out. All right. It was 0.0823, is that correct? Let's see, 0.0, it's right there. 0.0823, let me zoom out. And where is that? That is matching with this and with that. So the z-score is what, everyone? Negative 1.39. That is correct. Ooh. So now that we have the z-score, look up. Here's my z-score now. Negative 1.39. How do we write that as a probability? Tell your neighbor if it's shaded to the left. How do we write that as a probability? All right. Okay, we were on that side. Let's go over here to the middle. Let's go with Carter. What do I write? Probability of Z less than or equal to? Very good. Negative 1.39. Hands, have you got that? That is correct. From 1 to 5, what control are you with that? 5 fours, 5 fours. All right. Send me your notes, please. Let me send you the screen. That's going to be live tonight's home play, guys. I'm going through the process with you to make sure you got it. All right, look at this one. Don't copy that one, but walk your neighbor through that one, how to find the z-score. How do you find the z-score for that one? Tell your neighbor what to do. Don't copy it, just talk it up with your neighbor. What do I do? Querying. First step. Put sentence into a decimal so it gives us point what? 7422. Then you look for that on the chart, and that's how you find your z-score and write your probability. All right, we got this, yes? However, what if I gave you a graph that looks like this? Copy that one, please. Last one. Copy that one, please. Let me send that to your screen. Remember earlier that we found the area between two z's? That means we need two z's, don't we? Question, don't we have the first one already? Tell your neighbor what this Z is worth. What is that Z worth? We're talking about Z, not percentages right now. Z. What is that Z worth? 0. That is correct. Now, what is the percentages of everything to the left of that Z, everyone? Percentage. 50%. And what is that in decimal form? Negative 0.50 or 0.50. Just leave it as positive for right now. All right. However, that's for the entire area to the left. Do we have the entire area to the left? No. We need to take away what area? From here to the left. Think about it. If this blue area is 43.32% and the entire area is 50%, how do we find this percent? Talk to your neighbor. How do we find that percent? All right, how do we find that percent? Let's go with Santi. Subtract, 50% minus 43.32%, and that gives us 6.68%. That's this part. Change that into decimal, move this twice, so that gives us 0.0668. We look for that on your chart to the left. What is that Z-score, everyone? I need the Z-score. All right, looks like Austin's got it. David's got it. Looks like Maximus got it. For the sake of time, Austin S., what is that Z-score? Negative 1.5. So the Z-score for that green one right here is negative 1.5. The Z-score for mu is 0. So how do we write that in probability format? Negative 1.5 and 0. Z in between, less than or equal to, less than or equal to. Bless you. Send me your notes and then log out. And that's the home plate for tonight. From 1 to 5, how comfortable are you with this so far? Okay, good. 5 fours, 5 fours. All right. Once again, if in doubt, do your home plate. Woo! How about them apples? Bam! All right, those of you following on YouTube, make sure you put in some time doing your practice. Once again, there's the code to access the home plate. And this is what it looks like for tonight. Only 5 problems. See you guys next time. Peace.